here we meet again. Let's continue our exploration to the world of trigonometry. Are you ready?
Yes, ma'am.
Yes, we are ready. So, let's begin. But wait a minute. Let's recall what we learned last time. Last time we learned that trigonometry is a branch of mathematics that deals with the relationships between the sides and angles of a triangle. Historically, it was developed for astronomy and geography. Besides other fields of mathematics, trigonometry is used in physics, engineering and chemistry. The Pythagorean theorem and similar triangles, both of these are used over and over in trigonometry. Now, after getting acquainted with the meaning of the trigonometry and its uses and application, let's explore little more about the trigonometry. As we know that trigonometry deals with the relationships of sides and angles of a right triangle, the concept of angle is one of the most important aspects of trigonometry. In trigonometry, we measure the angle. The subject of the trigonometry is based on the measurement of an angle, and we know that we can measure an angle in two units. One of the common used unit of angles is degrees. A circle is divided into 360 equal parts and each part is called a degree. Degrees can be further divided into minutes and seconds also. If a degree is divided into 60 equal parts, each part is called a minute, which further on dividing into 60 equal parts is called a second. Usually, if we consider an angle on a coordinate plane, then the vertex of the angle is taken at origin with the coordinates 0, 0. One of the arm is taken along the x-axis and the other arm is taken above the x-axis. The other unit of angle is radians. For the radian measurement, take a unit circle. What is a unit circle? A unit circle is a circle with radius 1. And the angle we mentioned where we take the vertex at origin, if we represent that angle at the center of this circle, then we get a picture somewhat like this. Here we are considering the unit circle whose center is the vertex of the angle in question. Then the angle cuts off an arc of the circle and the length of that arc is the radian measure of the angle. So we can say that radian is the length of the arc cut off by an angle whose vertex is the center of a unit circle. It is easier to convert these units into each other. Now let's see the relationship between degree and radians. The circumference of the entire circle is 2 pi. So it follows that 360 degree equals 2 pi radians. Hence 1 degree is equal to 2 pi upon 360 radians, that is pi upon 180 degree radians, and 1 radian is equal to 180 upon pi degrees. So this is the way we can convert radians into degrees and degrees into radians. As we know that trigonometry is based on the angle measurement, and measurement of these angles can be associated to the measurement of the straight lines, and these generate few trigonometric functions such as sine, cosine, tan, etc. Let's consider one such straight line which is associated with angle measurement. It joins the 2 points on a circle. Do you know what this line is called? Yes, your guess is right. It is called a chord. So let us consider an angle AOB. In the diagram shows the curve connecting A to B be an arc of a circle. The straight line AB is the chord. Of course, the length of the chord depends on the radius of the circle. In fact, it is proportional to the radius of the circle. The known first trigonometric table was a table of chords. In modern times, sine is used instead. let's explore the relation between sines and chords. Sines and chords are closely related. Sines were first used in India. Sine is half of a chord. Do you know that history of sine is very interesting? It follows the path from India to the Arabic language, then to the Latin language, and then to the modern language of English. The Indian mathematician Aryabhatta used the word ardhjya for the chord, which was later translated to jiba in Arabic, and finally it came as sinus in European language, and then in modern language it is used as sine. Let's understand the meaning of sine with this bow and arrow diagram. Consider the angle BAD in this figure and assume that A is the center of a circle of unit length. Do you remember the unit circle we talked about earlier? Yes, unit circle is a circle with radius 1, and we are taking the vertex of this angle at the center of this circle. Let the point C be the foot of the perpendicular dropped from B to the line AD. Then the sine of angle BAD is defined to be the length of line BC, and it is written as sine BAD. You can double the angle BAD to get the angle BAE, and the chord of the angle BAE is B. Thus, the sine BC of angle BAD is half the chord BE of angle BAE, while the angle BA is twice the angle BAD. Therefore, we can say that the sine of the angle is half of the chord of the twice of the angle. We can use properties of similar triangles to relate the sines of triangles. Let us consider triangle ABC in which angle C is right angle and a hypotenuse of length 1. Consider a similar right triangle AB-C with a hypotenuse of arbitrary length. Since the triangles are similar, the ratio BC to AB equals the ratio B'-C' to AB', but AB equals 1, hence BC is equal to B'-C' upon AB', but BC is sine A as we defined earlier. Sine is half of the chord. Sine A is equal to B'-C' upon AB'. This result is most easily remembered as the sine of an angle in a right triangle equals the opposite side divided by the hypotenuse. Let us consider the standard notation of triangle once again. Consider a right triangle ABC with a right angle at C. We use the letter A to denote the side opposite angle A, the letter small b to denote the side opposite angle B, and the letter C to denote the side opposite angle C, that is the hypotenuse. With this notation, sine A is equal to A upon C and sine B is equal to B upon C. Now let's take another trigonometric ratio which is called cosine. Cosine is the complementary of sine. Cosine can be defined as the sine of a complementary angle. Complementary angles are the angles whose sum is 90 degrees. As you know that we are considering a right triangle here, so one angle is 90, so sum of the other two angles is 90. So that makes them complementary of each other. Let us again consider a right triangle ABC with a right angle at C. Since the sum of the angles of a triangle is equal to 180 degree and angle C is 90 degree, that means angle A and angle B adds up to 90 degree. That is, they are complementary angles. Therefore, the cosine of A equals the sine of B. We know that sine B is equal to opposite side over the hypotenuse. As we have seen earlier that sine B is equal to B upon C, that is opposite upon hypotenuse. Therefore, the cosine of A equals the B upon C. In other words, cosine of an angle is equal to the adjacent side divided by the hypotenuse. Also, cos B is equal to sine A, that is equal to A by C. Sines and cosines are not the only trigonometric ratios used in the trigonometry. Many more have been used through ages. One of the most important trigonometric ratio is tangents. Let us consider unit circle once again. Do you know what is a tangent? Tangent is a line touching a circle at one point. So you can see here in this diagram, ED is such line. So tangent is the length of the vertical line ED. Tangent to the circle from the point E to the point D, where the tangent line cuts the ray AD, forming the angle. Since the two triangles ADE and ABC are similar here, so we can say that their sides are proportional. So we can write this relationship as ED upon AE is equal to CB upon AC. But ED is equal to 10A here as per the definition of a tangent. AE is 1. Why AE is 1 here? Yes, the radius of the circle is unit here. Similarly, CB is equal to sine A and AC is equal to sine B. But we know that sine B is equal to cos A. So we can derive this fundamental identity from this relationship, that tan A is equal to sine A upon cos A. Just as sine and cosine can be found as ratios of sides of right triangles, so can be tangent. We will use these relationships here. First, tan A is equal to sine A upon cos A. Second, sine A is equal to A upon C and cos A is equal to B upon C. If we replace these values in this identity, what do we get? We get tan A is equal to A upon B. That means we can say that tangent of an angle is opposite side divided by hypotenuse. Before we end this session, let's recapitulate what we learnt today. We have learnt that trigonometric ratio of an acute angle in a right triangle expresses the relationship between the angles and lengths of its sides. Before we conclude our session, let's try to complete these sentences. Will you try to try? The trigonometry is a branch of mathematics that deals with the relationships between the dash and the dash of a triangle. Are you noting down in your notebooks? Please note them in your notebooks so that we can tally it next time. A circle is divided into 360 equal parts, calling each part a dash. A sine is half of a dash. Sine A is equal to dash. Cos A is equal to dash. Tan A is equal to dash. I hope you all found this episode interesting and informative. In the next session, we will talk about few more trigonometric ratios and their variation with length and sizes of the sides. Before we part, here is an easy way to remember these relationships of trigonometric functions. It is pronounced as SOHCAHTOA. SOH stands for sine of an angle is opposite over hypotenuse. The CAH stands for cosine of an angle is adjacent over hypotenuse. The TOA stands for tangent of an angle is opposite over adjacent. Another interesting way of remembering is Oh heck, another hour of algebra. I promise I will not bore you with algebra next time. We will continue our journey of trigonometry. Till then, goodbye. Have a nice day.